know.
Yes, ma'am.
Okay, because yesterday I have seen it is only 65 students. Out of them, 15 students are from other university and other colleges. So it means that 50 students of our university on that also we can classify this to be first year ke 25 the or second year ke 25. It means that only 25 students of your batch are attending all the guest lectures. See, I hope you understood from the last two guest lectures that these guest lectures are important for you for your competitive examinations. बरोबर ना?
Yes, ma'am.
So everyone should attend all the lectures. It is for you people only. We are arranging the lecture. All the guest lectures are doctorate and they have their own good command on their particular topic. Okay, so we were discussing about the geographical patch right now. So how this rectangle can be converted into the globe, and then we have seen whether it is a patch and why it is called a geographical patch. Okay, this geographical mapping, what it is found, it is called a geographical patch. And next we have seen the example of a parameterization of a cylinder. Okay, what for that we have seen that we have to find out xv cross xv, and if it is not equal to 0, it ensures that we have a cylinder whichever defined in our differential geometry is it has a parameterization. Parameterization का meaning क्या है? यहाँ पे पैरामीटराइजेशन चेक करना मतलब रेगुलरिटी चेक करना है. ओके, व्हाट डू यू मीन बाय चेकिंग अ रेगुलरिटी? एक्स यू क्रॉस एक्स वी इज नॉन जीरो. ओके, now let me go for the next point, that is parameterization of a surface of revolution. आठवतंय ना सगळ्यांना काय काय बघितलं होतं?
Yes, ma'am.
If you are not remembering, we can repeat some of the things which we have seen. Okay, parameterization, so meaning reparameterization. First chapter we have seen reparameterization. Okay, writing a given curve in the form of a parameterization is a in terms of parameterization. Reparameterization means what? Changing a parameter t to s. Okay, यहाँ पे भी हमें वही देखना है parameterization, but in the surface of revolution. Okay. So let me go for the next point, parameterization of a surface of revolution. Parameterization for the surface of revolution. Okay, so what is there? Find the parameterization of surface of revolution obtained by revolving the curve C, which is in the upper half plane of the xy plane about the x-axis. ये वाला हमने parameterization, sorry, revolution already हमने देखा है. But now we want to find out its parameterization. Okay, find the parameterization of surface of revolution obtained by curve which is in xy plane obtained by revolving a curve C which is in the upper half of the xy plane upper half of the xy plane, and we want to revolve this about a x-axis. Okay, want to revolve this about a x-axis. So those who remember, we have seen this type of a revolution. Let me write down this one. Alpha is a curve from I to E3 whose the parameterization can be written as alpha of u is equal to g of u, h of u, and 0. Okay, let alpha with a curve from I to E3. Okay, we have a curve I o alpha from open interval I to E3, and here in E3 we are getting a curve can be revolved now. Suppose this is a curve in xy plane. Okay, we have to revolve this about the x-axis. Okay, so revolving about the x-axis. Suppose we have revolved about the x-axis. ओके एंड वी हैव अ कर्व इन एक्स वाई प्लेन. ये जो आपका है ये आपका कर्व है एक्स वाई प्लेन में और इसको आपको रिवॉल्व करना है. ओके एंड एज आई टोल्ड यू दैट सपोज आई वांट टू रिवॉल्व दिस पॉइंट. दिस इज सम पॉइंट. If you remember, I have told you this is a point on xy plane, and if I am going to revolve, I will get a circle. बरोबर ना? Yes, anyone remember we have seen this?
Yes, ma'am.
Suppose this is a point P and then after revolution it will come to some V, and this is what a radius, and we know that we have named this as some Q1, Q2 are the coordinates for the point P, and after rotating it comes to some position Q. Okay, we have written this to be Q and new point P with the coordinate P1, P2 and P3. Okay, so this is what Q2, that is x-axis is fixed, that is Q1 is fixed out. Okay, and Q2 means what? This is what your radius. Okay, Q2 is a radius and all this. We have seen this one. But now we want to find out the parameterization for that. Okay, so for finding a parameterization, suppose that a surface is obtained by revolving the curve in a upper half plane, xy plane, about the x-axis. Let alpha be the curve whose parameterization is given by. मतलब आपका जो कर्व अल्फा है उससे ही हम लोग फाइंड आउट करेंगे ना, because we have only the curve in xy plane. If we are having a curve in xy plane, we have to revolve this curve about the x-axis, and then resultant we are getting a our surface of revolution. So for that, let me write down, let alpha be the curve whose parameterization is given by, let alpha be the curve from I to E3 whose parameterization alpha of u is given by g of u, h of u, and 0, because we are saying that this is curve in xy plane, so z coordinate should be 0. बरोबर ना? So let me go for the next one. When the curve is rotated about a point, the same thing whatever we have seen. We have seen this with respect to the point. Point P, point Q has been now changed to position P. Then now this point is on the surface, so it has a three coordinates. Initially, it has only two coordinates. That three coordinates we have found with the help of taking the circle. It is parallel to YZ plane. बरोबर? After taking to YZ plane, we have found the y square plus z square is equal to q2 square. Then we have written y is equal to q2 cos v and q2 sin v. आठवतंय ना सगळ्यांना? Y is q2 cos v and z is q2 sin v. So in the very similar way, here we have to do when the curve is rotated about the point and the profile curve has been rotated through an angle V. Again, we have to consider some angle V. The point on the curve XUV with the same coordinate, that is x of UV, can be now written in the form of uh, that is, if we are having a revolution about the x-axis, if you remember, when you have a revolution about the x-axis, we write x of uv is equal to x of uv. Now it will be three coordinates x, y, and z. And how to find out these three coordinates? With the help of original one, जो आपके पास है g of u, h of u, and 0. These are with us. Now, if the revolution is about x-axis, if you remember, we have written this as in the classical mechanics paper we have done this type of a revolution about x-axis, y-axis, z-axis. So if revolution is about x-axis, so first row and first column will be 1 0 0, and this next one is cos v minus sin v and sin v cos v.
Cos.
ओके, सो ये जो आपका एक्स ऑफ यू भी आएगा, क्योंकि अभी आपने पैरामीटराइजेशन फाइंड आउट करना है, राइट? सो इफ यू वांट टू फाइंड आउट द पैरामीटराइजेशन एक्स ऑफ यू वी इक्वल टू, नाउ इट इज इन द 3D space, क्योंकि firstly you have a curve. Now this curve can be now converted into the surface of revolution. It has three coordinate. Now these three coordinate I can find out with the help of the given coordinate g of u, h of u, and 0. And what is the surface of revolution? We have a revolution about the x-axis. So we have to find out this revolution about the x-axis with the help of a matrix. हे आधी पण केलं होतं क्लासिकल मेकॅनिक्स मध्ये, and I hope I have shown you this in the rotation in the type of isometry. Okay, those who don't remember, yeah, you can go to the lectures of isometry where I have shown you in detail how the rotation comes. Okay, so go through the topic of rotation, types of isometry, translation, rotation, orthogonal transformation. So translation क्या होता है, एक फिक्स वेक्टर से हम लोग पॉइंट को मूव करते हैं ना. नेक्स्ट वन, रोटेशन मीन्स व्हाट, वी हैव अ रोटेशन थ्रू सम एंगल v, and if some angle theta, phi, whatever we consider. And what about the orthogonal transformation? It must be linear and it preserve the dot product. So those who don't remember, go back to the isometry and you can see the how to find out the rotation matrix. Okay, now just do a multiplication of matrices and then we can get the value of x, y, z is equal to chi nr x, y, z is equal to. I hope you can do the calculations. Now, as you can see, this is a 3 cross 3 matrix and this is 3 cross 1. So, resultant you will get 3 cross 1. That is, I will get simply g of u. Then I will get it is, the first will be 0, h of u cos v. Again, this third one is 0. Again, the first is 0. Then again, h of u sin v. And the last one is 0. Barabar, no?
Yes, ma'am.
Simply we have to do the multiplication of matrices. Okay, so in this way I can say that xyz, that is x of uv, that is our parameterization, is written in the form of g of u, h of u, and cos v here, then h of u, sin v. Okay, so in this way we have found this. uh, Now if you remember, we have done this with the help of taking this in the yz plane, right? So अब हमें क्या करना है, we have to find out whether it is a parameterization, बरोबर? So if I want to find out if it is a parameterization, so क्या करना पड़ेगा आपको, एक्स यू एंड एक्स वी फाइंड आउट करना पड़ेगा, राइट? सो इफ आई वांट टू फाइंड आउट एक्स यू, what is x u derivative with respect to u, that is g dash of u, and h dash of u cos v as it is, again h dash of u sin v as it is. Next we want to find out xv, so which is 0. Again derivative with respect to this is minus h of u as it is, derivative of cos is minus sin v, and then derivative of sin is cos v. Okay, now we have xu and xv both with us. Now you have to find out just xu cross xv is equal to. Yes, what will be the value of xu cross xv? First row is fixed out. What is our first row?
U1, U2, U3.
Okay, so we have the first row is u1, u2, u3, and the second row is g dash of u, h dash of u cos v, and then h dash of u sin v. The third row is 0 minus h of u sin v and h of u cos v. Okay, so after doing the calculation, can you tell me whether x cross xv is non-zero? Do the calculation and tell me whether x cross xv is non-zero or not. So if you want to check the coefficient xu cross xv is 0 or not, you want to check the coefficient of u1, u2, u3. So if coefficient of u1, u2, u3 all are 0 simultaneously, it means that xu cross xv is 0. Okay, होईल का हे चेक करा सगळ्यांनी, सॉल्व करा ते डिटर्मिनंट. We have done this already, no? हमने ऐसे किया है examples. xu cross xv is equal to u1, if I have taken common, then you can get it is cos square v. So h of u and h dash of u I can take common, and I can have this as a cos square v, and again I can take common this term cos square v plus sin square v, दोनों सेम आएंगे ना, minus minus become plus. The next term is minus u2, then we have g dash of u, h of u cos v. Next term is u3 plus next term u3. We have it is minus h of u, right? G dash of u and sin v. ओके सो ये एक्स यू क्रॉस एक्स वी इक्वल टू जीरो कब होगा, ये वाला और ये वाला टर्म जीरो होगा, राइट? सो व्हाट आर द टर्म्स, लेट मी राइट डाउन फर्स्ट. एक्स यू क्रॉस एक्स वी इज इक्वल टू u1, the coefficient of u1 is h of u, h dash of u, plus next term is u2, with negative sign we have g dash of u and h of u cos v. Next term is u3, with again negative sign we have h of u, g dash of u and sin v. Okay, so whether all this coefficient will be equal to 0 simultaneously, it is not possible. Why this is so? Because g of u and h of u will not be equal to 0 simultaneously, right? अगर g of u h of u simultaneously equal to 0 होते हैं, इसका मतलब आपके पास कर्व है ही नहीं, right? g of u h of u यहाँ पे हमने क्यों लिखा था? Because we know that this is a curve in xy plane. So if it is a curve in xy plane, so g and u will not be equal to 0 simultaneously. So if we want to say that x u cross x v is non-zero, so g of u and h of u are not constantly zero. We can say not simultaneously zero, and sin v and cos v are not zero simultaneously. क्योंकि आप देख सकते हो u coefficient of u2 is cos v and coefficient of u3 is sin v for the same angle. v is the same angle, cos आणि sin दोन्ही same angle साठी zero असू शकतात का?
No, ma'am.
No, ma'am.
Possible? No. So for that, you can say that cos v and sin v simultaneously cannot be zero, as well as g of u and h of v cannot be zero simultaneously, since we can say that we have a curve in xy plane. That's why we can say x u cross x v will not be equal to zero simultaneously, which implies that we have x is regular mapping. Okay, so x is regular, it ensures that mapping x is regular means what? We can say that this has a parameterization. Okay, any doubt for this example? इजी है, आपने जो पहले देखा था सेम वैसा ही, वहां पे आपने p1 p2 पॉइंट्स को लेके किया था, और यहाँ पे आपने h of u g of u ऐसे एक फंक्शन इन u कंसिडर किया है, क्योंकि कर्व अगर आप xy प्लेन में कंसिडर कर रहे हो तो y is equal to f of x होगा, और you can say v is equal to f of u, so it is a curve in terms of u. So if it is a curve in terms of u, then write it as g of u h of u, then you have to revolve this and then you will get a surface होगा, तो obviously we have a three coordinate, that three coordinate you can find out with the help of a rotation matrix जो आपने rotation किया था. If you are going to revolve about the x-axis, you are getting this 1 0 0 1 0 0 on the first row and first column, and then you can multiply those and you can get the result. Is it okay?
Yes, ma'am.
Okay, now let us go for the torus of revolution. Okay, next point is a torus of revolution. So how to find out the torus of revolution? Surface of revolution we have seen. Okay, if you remember surface of revolution के लिए हमने क्या किया था? If we have a circle, half circle, so we can construct a sphere with the help of that, but it is not a surface of revolution because it touches the axis of revolution at the two different points. In the very similar way, we can see that this also, our cone is also going to touch your axis of revolution at the one point. Okay, so these are not an example of surface of revolution. In the very similar way, now we'll go for the next point, that is torus of revolution. Okay, so for torus of revolution, as you remember, we have seen this earlier also, that torus of revolution I can consider to be tube in the tire. Okay, tube of a tire. I hope you have seen. Those who haven't seen, for them I can give an example of a मेंदू वड़ा, जहाँ पे मेंदू वड़ा का जो अंदर का स्टफिंग है वो नहीं है, ऐसा कंसिडर करना है. Okay, we don't have any stuffing in that. So क्या करना है आपको? Suppose you have a curve in xy plane. Instead of saying curve to be in the xy plane, I can say we have a circle. So you have to revolve the circle about a fixed axis. It may be x, y, or z axis. So after revolving, whatever you get the resultant, it is called a torus of revolution. Okay. So how to do that? Now the same example will go. Find the parameterization of a torus of revolution obtained by revolving the circle of radius r with center at capital R 0 0 in the xz plane about a z axis. मतलब आपको रिवोल्यूशन अबाउट z एक्सिस लेना है और आपका जो कर्व है वो xz प्लेन में, राइट? सो इफ यू आर हैविंग अ कर्व इन xz प्लेन मींस व्हाट? यू हैव सर्कल इन xz प्लेन, और उस सर्कल को जो आपके पास है xz प्लेन में उसको आपको रिवॉल्व करना है अबाउट अ z एक्सिस. ओके, let me write down the question. Find the find parameterization of torus of revolution obtained by revolving torus of revolution obtained by revolving torus of revolution obtained by revolving our curve in xz plane, the circle of radius r, circle with radius r in xz plane, center at capital R comma 0 comma 0 about a z axis. Okay, so whatever given, we will write down this in the form of a figure itself. Okay, क्या करना है हमको? Find the parameterization of torus of revolution obtained by revolving the circle with radius r in the xz plane. Okay, let me write down first xz plane. xz plane में क्या है? उसका center क्या है? Capital R 0 0. Okay, this is what your x-axis, and suppose this is your z-axis. So center at R 0 0, and what is your radius? Okay. So here now the center is r comma 0 0 and the radius is small r, और इसको आपको z plane के around घुमाना है. Okay. So whenever you are going to revolve this about a z plane, you will get an object. This is called a torus of revolution. Okay. Try to imagine. Everyone just draw this on the your rough note whenever you come for lecture. I hope you are having some notes to write down. सो क्या करना है आपको? ये वाला जो आपका सर्कल है उसको अराउंड z एक्सिस आपको रिवॉल्व करना है. ओके, सो अगर आप रिवॉल्व करोगे तो नो डाउट इट विल बी नाउ इन द 3D स्पेस. सो हियर यू विल हैव अ y एक्सिस. So after revolution you will get some object in a 3D space. Let me draw this. I will try to draw this because my drawing is not so much perfect. X, Y, Z. So we have, this is our Z axis, this is our X axis, and this is Y axis. So we have a curve. क्योंकि हम रिवॉल्व कर रहे हैं वो अभी xz प्लेन में से चला जाएगा, राइट? सो नाउ सपोज दिस इज व्हाट अ सर्कल, बड़ा वाला सर्कल हो जाएगा ना. सो दिस इज, assume that this is what firstly here it has some position, and after some time it will be at some this position. Okay, लेट मी शो यू द एक्चुअल इमेज क्योंकि मुझे उतना अच्छा नहीं आ रहा है ड्रॉ करना. ओके, सो टोरस यू कैन इमेजिन So now you can see the Torus of Revolution on your screen. It is in the form of donate to itself. Donate जो आपका होता है ना वैसे ही होता है. This is what a revolution, Torus of Revolution. और हम जो एग्जांपल देख रहे हैं वो ऐसा वाला है. Okay, we have to revolve this about some axis, some radius r is fixed out. ये सेंटर पे कभी नहीं हो सकता है. ओके, क्योंकि अगर वो सेंटर पे होगा तो रिवॉल्यूशन तो पॉसिबल ही नहीं है, क्योंकि अगर वो एक्सिस ऑफ रिवॉल्यूशन को अगर टच करता है तो ऑब्वियसली इट इज नॉट अ surface of revolution, so it is somewhat away from the origin center, that is 0 0, and then you have to revolve, and whatever the object you are getting, it is a torus of revolution. Yes, can you see this?
Yes, ma'am.
Yes,
Yes,
ma'am.
okay. We have to revolve this about some particular axis, either x, y, or z, and then you can see. Okay, this is what a torus of revolution. Okay, this is what the figure I want to draw. Uh, so you can see the different positions of your circle, as this is revolving about a z-axis. If it is revolving about a z-axis, so it is having some different position. Okay, and then whatever the object we are getting, it is called a torus of revolution. Okay, I hope you understood this, how to find out the torus of revolution. Now let us continue with this, that we have to find out the parameterization for that. Okay, so here we found the, first we have a circle in xz plane, then revolve this about the z axis, and whatever the object you are getting, it is a torus of revolution. Okay, now what is our next point? We want to find out the parameterization for that. Okay, so for finding the parameterization, first we should know what are the parameters for the given curve. Okay, so for the curve, we have a curve in a, or we can say the circle in xz plane. Okay, if I say this is a circle in xz plane, so center is at r now, so x axis के यहाँ पे आपका center है. So can I write this as x minus r square plus z square is equal to small r square? This is what a equation of a circle in xz plane for this case. Is it okay?
Yes, ma'am.
Yes,
सेंटर
ma'am.
ओरिजिन नहीं है ना, तो एज इट इज सम डिस्टेंस from origin to x axis, so that's why we have written like this. So now we have a circle in xz plane, so I can write this as, we have this curve circle. uh, Now we can write down them in terms of a parameter, as we can write x is equal to some r plus r cos u, and y is equal to r sin u. Is it okay? r
Yes, ma'am.
cos theta r sin theta लिखते हैं ना हम लोग. Now but it is at some distance r from the origin, so hence capital R plus r cos u and r sin u. Okay, this is what x and z coordinate. So if it is x and z coordinate, so I will write down the curve alpha of u as x coordinate is r plus r cos u, and z coordinate is r sin u. So this is what our curve. Now our aim is to find out what is the parameterization for the torus of revolution. जो आपका 3D ऑब्जेक्ट मिल रहा है, उसके लिए आपको find out करना है. Now we know about what are the limits for the u, because we are in the circle, so I can say the limits are 0 to 2 pi. Now we want to find out the parameterization. It means that x of uv we have to find out. Now we have found the revolution about a z-axis. So if the revolution is about a z-axis and x of uv, I can write it as x, y, z will be equal to the revolution. Now it is about a z-axis, so 1, 0, 0. Correct. Here we have cos v minus sin v, and here we have sin v, cos v, and here we have the coordinates which we have written. ये वाला आपका आएगा r plus r cos u 0 r sin u. Okay. So now we can find out parameterization with the help of just multiplying the two matrices, and then we can get this in terms of x of uv is equal to. Yes, everyone understood this step? आपको न्यू पैरामीटर अगर फाइंड आउट करना है तो पहले वाला का हेल्प लेना पड़ेगा। ये वाला है जो आपका कर्व है, कर्व के हेल्प से आपने सरफेस ऑफ रिवोल्यूशन फाइंड आउट करना है, और रादर यू इन दिस केस यू कैन से इट इज टोरस ऑफ रिवोल्यूशन. Now revolution is about z axis, so 0 0 1 and 1 0 0 1, and this is about the z axis. So that, sorry, actually I think I am wrong. About a z axis है ना, तो आपको कैसा लिखना पड़ेगा about z axis? The last one it is 0 0 1. Okay, so here we have cos v minus sin v and sin v cos v. Okay, ये वाला wrong है क्योंकि 100 इधर आना चाहिए। जेड एक्सिस पे रिवोल्यूशन है, मतलब जेड जेड फर्स्ट वाला जो जेड कोऑर्डिनेट है और न्यू वाला जो दोनों कोइंसाइड होंगे, इसका मतलब यहाँ पे 1 आएगा। सो आर प्लस आर कॉस यू and 0 r sin u. Then you have to multiply the two matrices and then we get the result x of uv is equals to xyz is equal to, now it is 3 cross 1 matrix, so I can write directly to be just multiplication of these two, cos v r plus r cos u, second and third will be 0 again, this next one sin v multiplied by r plus r cos u, and the third one again we get simply r sin u. Okay, yes, everyone agree with this?
Yes, ma'am.
Okay, so here we get a parameterization now. Now simply we want to find out what is a in terms of parameter, and the next step we want to find out x, so u x v and then x u cross x v. Okay, so can you do this x u cross x v find out kara x and check kara कि whether it is a regular or not. Okay, yes, everyone have to do this now. Find out x u x v, that is you have to differentiate with respect to u and then differentiate with respect to v. Then find out x u cross x v. First row is u1, u2, u3. Second row is coordinates of x u. Third row is coordinates of x v. Check whether it is non-zero or zero. As it is a combination of sine and cos, obviously it will not be equal to 0. Okay, but still you have to do. Solve करा सगळ्यांनी.